Find the derivative of a function with sine and cosine. So in this video, we're going to learn how to take the derivatives of our first two trigonometric functions, sine and cosine. So let's dive in and let's look at these formulas. Alright, so our first formula we're going to learn is taking the derivative of sine of x. And well, the derivative of sine of x, as it turns out, is cosine of x. And you could prove this derivative by doing the limit definition of a derivative by doing f of x plus h minus f of x all over h. You have to use some fancy trig identities such as the sum and difference identities for sine and cosine, but eventually you would end up with cosine. Well then, the derivative of cosine is going to be negative sine. And this, again, sometimes is a trap for students because they think, oh, well, sine turns into cosine and cosine turns into sine. And they often forget about that negative. So please make a point to remember that the derivative of cosine is negative sine and not just sine. So let's see how to use these derivative formulas as we take a look at this example. So we're being asked to find the derivative of the following function, and the function we have is y is equal to 3 sine of x. Alright, so I'm going to use a little bit different notation here than we might have used in the past. And again, that's just to get you used to seeing the different notations that you might come across in different resources that you use. So we're going to start out with our function. We're going to have y is equal to 3 sine of x. And we want to take the derivative of this function, which means we'll just take the derivative of both sides. Well, d dx of y, we know from a previous video that we can rewrite as being dy over dx, meaning that we have already taken the derivative. And then we just have to figure out, well, how do we take the derivative of 3 sine of x? We know what the derivative of sine is, but what do we do with that 3? Well, fortunately, in a previous video, we talked about how, if you have a coefficient to the function, you can just factor that out of the derivative, meaning that we can pull the 3 out, and then we can just take the derivative of our sine function. And then we'll go ahead and do that. So dy over dx, which represents the derivative of y, is going to be 3 times cosine of x, because the derivative of sine is cosine. Alright, our next example, we're going to take a look at finding the derivative of y is equal to 7 cosine of x minus 4. Alright, so I'm going to, again, solve this one with a little bit different notation, again, just to get you accustomed to the multiple notations that there are. And we've already used this one in previous lessons. When we take the derivative of y, we can just use y prime. And that is going to be equal to. And as we saw on the last slide, or from previous videos, we know that when we take the derivative of a function that has a coefficient, say, I don't know, 7, since we have that rule that says we can factor out the coefficient, essentially that means that we can just ignore the coefficient and take the derivative of the function. And the derivative of cosine, remember, is negative sine of x. And then we have the minus 4 there, and the derivative of 4 is 0, because the derivative of any constant is 0. And then finally, we just need to simplify, so y prime is going to be negative 7 sine of x. Alright, next up, we want to find the derivative of y is equal to 4 cosine of x minus sine of x. So let's go ahead and let's just take the derivative of both sides. So we're going to have d dx of y is equal to d dx of 4 cosine of x minus sine of x. And in this particular problem, as you see, we're going back to using the d dx notation as opposed to the primes. And as we saw before, if we want to take the derivative of y, that's just going to be dy over dx. And again, this implies that the derivative has been taken. Well, now we have the derivative of 4 cosine of x minus sine of x. And we know that if we have addition or subtraction, we can take the derivative of each piece individually. Meaning we're going to do d dx of 4 cosine of x minus d dx of sine of x. And like we have already talked about, if we have a function that has a coefficient, we can essentially ignore the coefficient and then just multiply it by the derivative. And the derivative of cosine is negative sine of x. And then minus, and then the derivative of sine of x is going to be cosine of x. And then all we have to do is kind of just simplify this down, giving us an answer of negative 4 sine of x minus cosine of x. And there we have it, our derivative. And our final example is asking us to find the derivative of y equals negative cosine of x plus 4 sine of x at the x value negative pi over 2. So we are going to need to use the unit circle here. So if you don't remember what it is, it might be a good idea to go grab it as a reference. Well, before we can plug in our x value, we first need to find the derivative. So let's see. The derivative is going to be dy over dx is equal to, and then we have the negative in front, that's going to stay alone. And then the derivative of cosine is going to be negative sine of x. And then plus, we can ignore the coefficient, that's not going to change. And the derivative of sine is cosine. Alright, then we'll just take that extra step and we'll simplify this down, because negative times a negative is going to give us a positive sine, and then plus 4 cosine of x. And this derivative, again, is the formula to find the derivative at any point on our function, but we don't want to find the derivative at any point. We want to find the derivative at x equals negative pi over 2. So that just means we're going to substitute that means we're going to substitute negative pi over 2 for x into our derivative. So we're going to get sine of negative pi over 2 plus 4 cosine of negative pi over 2. And I might be asking yourself, wait a second. There are no negative angles on the unit circle. And you would be right. However, we just need to find what this negative pi over 2 position is on the unit circle. And we know that we can change a negative angle into a positive reference angle by adding 1 full rotation, or 2 pi. So that's going to give us sine of 3 pi over 2 plus 4 cosine of 3 pi over 2. And then we can use the unit circle to evaluate. Sine of 3 pi over 2 is negative 1 plus 4 times cosine of 3 pi over 2, which is 0, giving us negative 1 plus 0, or a derivative at x equals negative pi over 2 of negative 1. Alright folks, and there you have it. That is finding the derivative of a function with sine or cosine.